So I'm Stefan Setzer from Rwth Aachen University and giving a report about the TNA called Visualization of 4D Discrete Data of Sand Grain Kinematics Under Loading. The project partners in this case were from Laboratoire Y4S4, Sino Vichani, Edward Ando, Frederic Noel, and Patrick Bengo. And from the VR group at Rwth Aachen, it's myself. The whole thing is still work in progress. The goals of the project are as follows. Dr. Ando, the scientific challenges in this project were to better understand the computations simulations that Professor Dr. Ando did in his thesis. Our part was to or the understanding of his work should be achieved by an interactive interface to explore and analyze the data that he computed, and this should be done in a virtual environment like our cave at Rwth Aachen. And to achieve this, we had to develop or make an interactive interface and visualization to show the data and visualize, explore it, and analyze it. Project progress as this. We had as a starting point, I got some test data. Consisted of 14 discrete time levels, each of which had 200 grains. The sand grains were substituted as tubes, as you can see in the image below, and we had a data feed mapping the cell IDs to the grain IDs. To make a visualization and interactive visualization in virtual environments, the idea was as followed. We wanted to adapt established visualization and interaction metaphors for pathlines from flow visualization, where we already had some things developed at our site. And to do so, I computed trajectories of the sand grain movement over time using the IDs given in the dataset. The visualization then of these trajectories can be done with a VR application that we developed at our place based on Vista and Flowlib and some other nice stuff to visualize, explore, and analyze time-dependent scientific data in virtual environments. Especially we have some advanced interaction method developed for direct navigation of time, where we can in this case select distinct trajectory or grain and intuitively navigate it through time by dragging a handle along the selected trajectory, as you may see on these pictures. I will show you how this looks in a video. If you stop the simulation and grab one of the particles and one of the grains, then you can drag along the computed trajectory and explore very distinct points in time. That's what we've done so far. As I said, it's still work in progress. We have to evaluate this application and interaction method, whether it really fits, and we still have to, if this is the case, then we will have to do the actual access of the TNA at our site, which is still up to come. That was it so far. Thanks for your attention. I hope any questions.
In terms of complexity, the first step seems to be very low number of time steps and very low number of grains. Do you imagine that it is possible to upgrade all that easily, or do you think there will be a real computation problem?
Said it's just test data, so yes, it's very limited in the number of time steps and grains. I think that there will be definitely a computational problem when you expand this further. The computation of the trajectory as it is now is we have to load all of the time steps that have to be computed at the same time. So there definitely is a computational problem, as I said. For the computation of the trajectories, we have to load all the time steps at the same time to compute these at the moment. So that's one limitation here. You need a machine that is capable of loading everything. Regarding the visualization, we have to try things how much of the grains and trajectories can be visualized at the same time. We don't have an exact measure at the very moment.
Is it pre-computed?
Yes, they are pre-computed.